Sorry, so I should have explained this a little bit differently. I actually did have decimal before. I don't know why I changed it. So actually a better way to reference this is not the first digit. So I mean the first decimal is what I mean, right? So first decimal and second decimal, right? So first decimal, second decimal. And so what I mean by that is, so for the first decimal place you see, so 0.6 for example, you want to use your left column here and you want to go to 0.6. If there is no second decimal, you don't actually have to do anything else. You go to the 0.00. That's giving you the second decimal, but there is none. You could just say 0.60 if you really want to. And then this value here though, like that's your answer. But it's very important you understand what that answer actually is. What does that represent, the 0.257 or whatever?
Yeah, percentage of the thing.
Right, and think about it as a diagram. Like, I'm a visual person, right? So if you have your normal distribution and you're saying, okay, a z-score of 0.6, so here's your mean. If I have a z-score of 0.6, it's basically saying all the area to the left of that section, right? So that's what that's saying. The area to the left of 0.6 is 0.7257. Why it's important that you recognize what that represents is, like I said, you're going to have to make modifications later on about maybe it's not just less than or equal to, but maybe you have to do a few adjustments. Next one for me, Laura, what'd you get? So we go to negative 1.8 and you go to 0.336. So negative 0.03 is the second decimal, and yep, 0.0336. Perfect. This is a 2 apparently. Kyle, you got the next one for me? Yeah. I don't know if you can see this one. So we went 2.3, and then what do I do after that? 0.2. Yeah. So 4. 0.99. Oh, hang on, did I do that right? 9904, is that what you guys got? Yep. 0.9904. Does this matter? The fact that this is less than equal and this one's less than? No, why not? It doesn't, and the reason why is because a single outcome doesn't have any probability when you're looking at continuous probability distribution. Okay? So these two are effectively the same. But this one's slightly different. Hey, why is this one different though? Right, so we have emphasized that the idea is you can only use these for less than or equal to because that's what the value gives you, right? So when you're doing this, you kind of have a few options. Now, one thing I should stress is that in an exam, you may not get this full table. So you may only get a certain section of the table. So you have to rely on different approaches to this. Yeah. One of the approaches is to do what I just talked about over here. You said you could go to the other end of the score and then find that. Because if you think about z greater than or equal to 2.7, what does that look like visually? I'll do it here. So this is part D. What does this look like visually? Have a look. So these are your z-scores, right? It's symmetrical. We have 0 in the middle. Where's negative 2.7? Which side is that on? It's to the left, right? So it's negative 2.7 here. But this time, when you're asking for it greater than or equal to, right, I'm not getting the sections on the left. I'm getting the sections on the right. Yeah? So that puts us in a bit of a predicament, right? I can't just use negative 2.7. What could I do?
Positive 2.7.
Yeah.
The old sign.
Right. So what you could do is you could say, hang on. Well, although I can't use negative 2.7, because the normal distribution is symmetrical, what you can do is you can take a z-score of 2.7 and evaluate everything to the left of that. So these two are the same because of the symmetry of the normal distribution, right? You've got the same tail end that's missing there. So we could try that. So if we go to 2.7, and remember it's only the first decimal, so it looks like it's going to be 9965. And just think about it visually as well, like these numbers are meant to be pretty big now because you're getting a fair amount of area. So 0.9965. Yep. What's another option you could do though?
Subtract 1 from the answer of the negative.
Yes, because what you need to be aware of is that you may not always get every single section of the normal distribution. So when I said that, oh, the solution is just to go to 2.7. All right. Yeah, sorry, coming back. Sorry about that. So the other issue is that you may not always get all the sections. So you can't just rely on that one thing. Another option that you do have, if you're not given all the sections, is exactly as James said. You could say that this is equal to 1 minus P of Z less than or equal to 1. Yeah. There you go. Right, because the idea is, okay, if I have to rely on negative 2.7, then what I could do is, I know that the blue section is what the table finds, right? But the red section is what I want. And since I know that the area under the curve is equal to 1, well, if I just do 1, take away this blue section, can you see how you get left with that red section, right? That's the idea behind the normal distribution. Like the properties of the symmetry are very powerful here, and also the fact that the area under the curve is equal to 1, that's what you want to rely on. Yeah? Does that kind of make sense there? So if you went to negative 2.7, you'd see you have a value of 0. Oh, lost that one. Was it 0.035? Yeah? So here. So that should be the same as what? 1 minus that. Yeah? Make sense? Yeah? Any questions about that one? Last one. This one's a bit trickier. Oh, Laura, what did you do over here? Minus it. Just minus it. And again, like for me, I just like to think about things visually, right? What is this actual area that I'm trying to find? Well, if I think about it, I'll just draw the normal distribution out again, right? So if I go and I want between negative 0.3 and what positive 1.4, right? I want this section over here. And there's definitely no value in the table that's going to give me that answer outright. But what you can rely on is you can rely on the fact that you can find some areas separately. So that's negative 0.3. For example, P of Z less than or equal to negative 0.3 would be something like this. Right? And then P of Z less than or equal to 1.4 would be like this guy. Right? And remember, what's the area that you're trying to find? I want the one that's in between those two. So can you see what's the extra bit that you have? If you had this whole thing here, the extra bit that you have is this little tail here. So the idea is you would take this whole area, you would find that, and you would subtract it away from this one. Does that kind of make sense? Right? Yeah? Do you have those areas for me, Lauren? Yeah? What did you get? So 1.4 was, so you got 0.9192, and this one was negative 0.3.
Oh, no.
That's all right. Yeah, that's okay. So that area there is 0.38. Yeah, I just want to working out so you can see how it's all written. And so therefore, part E is going to be 0.9192, take away 0.3821, and what is that? 0.5371. Perfect. Okay, that's it. Any questions about that?